In section 8.6, we're going to be talking about various segments in a circle. And there's going to be three situations. So the first one is if I draw two random segments in a circle like this, we see that they intersect just kind of at a random spot in the circle, not necessarily in the center. And let's say I kind of label these parts of the segment as A and B and then C and D. The relationship for any two segments drawn in a circle like this can be this proportion. So A times B equals C times D. So the pieces of the first segment equals the pieces of the second segment multiplied together. Looking at an example, let's say I have this diagram and I want to solve for x. I would look at that first segment there, so I would do 8 times x equals 20 times 6. So now I have 8x equals 120, divide both sides by 8, and I have what x equals. And I'm done. Second situation, let's say I have two segments drawn that go all the way outside the circle. The way that I look at this situation, and also I'm labeling x, w, and z and y for the little pieces, the relationship here, and also for that the third situation we're going to look at, is outside piece times the whole segment equals outside piece times the whole segment. And looking at this diagram specifically, what I would mean by that, w and y are the outside pieces, times the whole segment, so times x plus w and then times z plus y would equal each other. So now let's solve for y given this diagram. I'm going to do the outside of this segment times the whole thing, which is 6 plus 8, which then is just 14, equals outside piece times the whole thing. I'm going to simplify, so this is going to be 84 equals, I'm going to distribute 49 plus 7y, and then I have a basic algebra 1 problem, and I'm going to solve for x, or y in this case. And I get that y equals 5. Our last situation I'm drawing out here, so I have a segment T, and then I have another segment, and I'm going to label it Z and Y. It's still going to follow the same pattern of outside times whole equals outside times the whole thing. It's just now when I look at this segment T here, the outside and the whole thing are the same. So I'm really just doing T times T equals Y times the whole thing. So I could kind of just write that as T squared. So in this example, our last one that we're going to do today, we have that segment Z and then that other segment 8 and 16. And I could write it like this. Z squared equals 8 times 8 plus 16. So Z squared equals 8 times 24. To solve for Z, I got a square root. And Z is about equal to 13.9 if I round to the nearest tenth.